I'm going to start the recording, and here I've just run my model. And first I'll go over to a profiler. This is a profiler here, okay? And I am going to, you'll notice that this is listing some information. I'm going to close this guy out. And I'm going to run this model. And I'd like you to note what's here right now. And I'm going to go run a large population. Okay? And you'll notice when I do that, what happened? Did anyone see that? Let me do that again, because it will be important for you to notice these things. You notice what's here? Do you see that? There's 2 items under local, right? Watch as I go to run this AnyLogic scenario. What happens? Well, there's a 3rd item added, isn't there? Okay, ladies and gentlemen, I'd like you to go right-click on this and do sample. Well, of course, you can't do this live, but you could do sample. There's actually 2 modes in which this runs. I'm going to show you the simpler one. And then you're going to be able to say CPU here. Now, first I'm going to start it running, the model, and the model is starting up, and I'm going to click on the CPU. And what it's going to tell me here is it's going to start recording here with this model, and I'll run it as fast as possible here. It's going to start recording here information on the sampling from this. So in other words, it's going to start recording what's going on within the context of this model. Okay, so here we actually see this running, and I'm going to. Okay, no, that's interesting. Let me close this off and again do sample here, and I'm going to do sample. Okay. Okay, so why isn't this showing? That's most unusual. It was working earlier. Okay, here's the amount of memory allocated. That's less of interest. Let's go back to CPU. Here we go. Yeah, there we go. It was just a problem with it showing. Do you see where this thing is spending time? What's the thing that's taking the most time right now? Trace LN. That's where I'm actually printing things out. And then there's a bunch of other things that are listed here. Now, some of them are fairly opaque. It's not clear fully what they are. For example, engine.k.f. However, some of them are more obvious. For example, with a bit of guesswork, this one here, you notice you see the name of the model, ABM Multi-ES Multi-Clinic Model, added in 2015. You'll notice there's this thing, count ill in population. What do you think that is? What sort of things live in population? It's a statistic. And that's actually taking about 10% of the running time right now. Okay? There's also some things with certain state charts unchanged associated with a state chart. But you can see a lot of things are in the noise here. Now, I would highlight for you, ladies and gentlemen, the fact that many of these things have to do with what? With the presentation, the visualization. There's a lot going on here having to do not with the model logic, but instead with the visualization of that. And there's nothing inappropriate about that, but sometimes if we really want performance, we want to put that aside. Okay? Can I show you a way to put that aside? Okay. So, ladies and gentlemen, we're going to just remember these hot spots, as they're called. I know it's a different type of hot spotting than most of you are involved in. And we're going to do stop here, and we're going to terminate this particular component. It saves it for us for later reflection. Okay, so that's one thing. You could do a similar thing, incidentally, with the memory. Okay, so what I'm going to do over in AnyLogic to help speed this up is I'm actually going to add in a parameter variation experiment, okay? And the reason is that this runs with no visualization, okay? I'm actually not going to use all the features of this. Later we'll see a little bit about that, but this will actually be running it with simply the default parameters. You see them here. Do you remember those parameters? Those are just the defaults, right? The difference is, ladies and gentlemen, when you have a parameter variation experiment, it's going to run the model many, many times in succession. And it does so without visualization. does so without trying to visualize it. Okay? And that can cut down very significantly on the computational effort. So it doesn't completely eliminate all visualization components, but it can greatly reduce it. So I'm going to right-click on that, and I'm going to say run here. And you'll notice that because I haven't really set this up, it's pretty much empty. But I could still run it through this button here. Meanwhile, I wanted to notice, okay, this is 3200 here. So I'm going to run this. And now I'm going to go say sample this process. Here's 3200. And I'm going to be collecting data on this. I'll go take a look at the memory. And this isn't nearly as helpful, but it can sometimes give you clues as to what's going on. And here, okay, looks like it doesn't have quite enough data yet to summarize. But within the context of this, we're going to see a different profile. Okay, so what is it that is keeping it from summarizing this more completely? It is correct that it's all in run, but oh, it's finished. That's why. Great. Great. So, oh, you know what? I needed to set, sorry folks, I needed to set the time associated with this. It only ran to time 100. I'm going to run it time never. Here we go again. Sorry about that. So let's go back to that. Okay, and there's this new process. I'm going to close this guy out, and we are going to say sample from it, and in the background, we'll let it run. Here it's still running. It's still running without visualizations, without all those sort of visual things. Here's memory used by it, and okay, well, it's still not providing us with much information. Oh, did I not? Oh gosh, I didn't hit it yet. Thank you. I thought I hit it, but okay, thank you. Great. Great, great. Okay, there we go. Okay, so you notice a quite different picture of where it's spending its time now. Now, this doesn't convey how much faster it is directly, but you'll notice that you basically have eliminated most of the presentation-related things. And even things like trace-ln are taking a lot less time. It's running headless. It's not showing, needing to show it and update it and scroll it and all those sorts of things. And so here, you're getting more time spent to the core logic, for example, here, waiting potentially for resources, calculating the distances between things. So parameter variation experiments, ladies and gentlemen, are your friend, not only for systematically interrogating a model as to its behavior as you vary parameters, great for that, but also for speeding up a model when you really want it to run faster. And I've seen models, very, very significantly sped up as a result of running them headless, running them without a visualization. Okay? Very easily done. Add a parameter variation experiment, and then get it to run through here. So this is another way in which you can get clues as to what things are taking time in your model. It's awful easy to fool yourself and to think, oh, this must be too big a burden. But if you can get empirical evidence as to where it's spending its time, it'll be much more, your time will be spent much better. Because certain things that you may think are a bottleneck won't be. And certain things will end up taking disproportionate time. So that's a little bit of a suggestion. The tool I'm using is called JVisualVM, and it's a free download from Oracle, and it comes with the Java SDK, I believe. Still a software development kit.
Very simple question. When was JVisualVM officially adopted by Oracle? I thought it was like an offshoot, but am I mixing up the tools? Has it always been supported by Oracle?
Yeah, well, Sun before Oracle, before Oracle. So Oracle bought Sun, who were the makers of Java. And JVisualVM, I believe, has always been in that lineage. There's another tool for Eclipse called TPTP, which I've also used with AnyLogic, and I think you'll find a video of me showing how to use TPTP within Eclipse. But that requires having Eclipse installed and all those sort of things. This is a standalone tool. It's very easy to use, and it can give you insights as to what's taking the time. Is it an event? Is it a explicit event? Is it something to do with my state chart? Is it something to do with the visualization? Is it something to do with a certain calculation I'm doing? These are useful things. Okay? So that was a little bit on a profiler.